Hello everyone. Today we are going to solve the problem of partial differential equation. Here is the two problem is given. We have to solve the in the live session of two problem. Let's solve the problem. Form the partial differential equation by eliminating the arbitrary function. First function is z is equal to f of y by x, and second function is z is equal to x to the power n f of y by x. Let's solve the problem first. Given function is z is equal to f of y by x. Let this is question 1. Differentiating partially equation 1 with respect to x, that is del z upon del x is equal to f dash y by x, and y by x is differentiating with respect to x, that is y is constant and 1 by x is minus of x square. Taking y is constant and y to the numerator, that is x power minus 1, and taking different partial differentiation with respect to x, that is taking y is constant, x to the power minus 1, x to the power nx, x to the power dy dx of, that is nx n minus 1. This is the formula used, that is y is equal to x to the power minus 1 into x to the power minus 1, that is minus of x to the power minus 2, taking into denominator, that is 1 upon minus x square. Then taking minus x square into cross multiplication, that is minus of x square del z upon del x, and y is also taken to denominator, that is y is equal to f dash y by x. Taking equation, this is 2, and differentiating partially equation 1 with respect to y, that is del z upon del y is equal to f dash y by x, and differentiating partially with respect to y by x, that is 1 upon x. Further, taking x into cross multiplication, that is x del z upon del y is equal to f dash y by x. This is equation 3rd. Using equation 2 and 3rd, we have to eliminate the arbitrary function, that is from 2 and 3rd, right hand side is equal, then the left hand side is also equal, taking into minus x square upon y, del z upon del y is equal to x del z upon del y. Minus of x square by y del z upon del y, taking into right hand side, that is x del z upon del y plus x square by y del z upon del x. Here del z upon del x, this is mistake. This is del z upon x is del z upon del y. One second. Del z upon del y, and this is del z upon del x. This is del x is equal to 0. This is the required partial differential equation of the given function, first function, and we have to solve another function. Second function is given, that is z is equal to xn f of y by x. This is also taken in equation 1. Differentiating partially equation 1 with respect to x, we get del z upon del x, and from here x and f of y by x. This is a two function, taking xn is the first function and f of y by x is the second function. That is, first function is, and second differentiation of the second function, that is f dash y by x, and differentiation of y by x, that is y upon minus x square, plus second function is f of y by x, and the differentiation of first function is first part, second differentiation, first function is differentiation of second function, this will differentiation of first function, that is x power n, that is nx n minus 1. This xn f dash, once again xn y upon minus x square f dash y by x plus nx n minus 1 f of y by x, taking equation 2, differentiating partially equation 1 with respect to y, that is del z upon del y equal to, from here del z upon del y, that is xn is constant, here all del z upon del y, xn is constant, f dash y by x and partial differentiating that is 1 by x, and from here x upon n, x power n upon x, f dash y by x. This is equation third, del z upon y. From here, multiplying equation 2 both the side by x, and multiplying equation 3 both the side by y, and adding equation 2 multiplying with x plus equation 3 multiplying with y and adding, that is adding left hand side to left hand side and adding right hand side to right hand side. That is equation 2 of left hand side is x del z upon del x plus equation third left hand side y del z upon del y is equal to, from here, that is multiplying x with this function xn plus 1 minus of x square f dash y by x plus on multiplication of x, that is remaining is n x power n f of y by x, and the left hand side right hand side of equation third is on multiplying with plus x and y upon x, x and y upon x f dash y by x. From here, that is xn plus 1, that is x power n into x. X power n, x to cancel out, that is remaining is x power n minus x f dash y by x, and from here that is nx power n f of y by x, and from here x is taken into numerator, that is x power n minus 1 into y f dash y by x. This is x del z upon del x plus y del z upon del y. Further, x is taken into numerator, that is x n minus 1 f dash y by x, and this is minus x del z upon del x plus y del z upon del y plus n xn f of y by x. This is also x n minus 1 y f dash y by x. We have to eliminate xn minus 1. Taking common xn minus 1 f dash y upon x, and taking common x e power n f dash y by x from this part to this part. Remaining is minus of x, and from here is plus of y, plus here is n, and x to power n f of y by x is x to power n f of y by x in place of putting z, that is nz. We have to put f dash y by x value from x n f. One second. F dash on partial differentiating with respect to y, that is del z upon del y is equal to xn is constant f dash y by x, and differentiating partially with respect to y, that is 1 by x. So the value of taking value from here, xn f dash, that is xn f dash y by x, and x is into cross multiplication with x del z upon del y. Putting the value here, that is x del z upon del y into minus x plus y plus nz. This is x del z upon del x plus y del z upon del y. Or multiply with the, that is minus of x square del z upon del y plus xy del z upon del y plus nz. And here is the x del z upon del x plus y del z upon del y. We can also common taking this function into left hand side, that is x del z upon del x plus y del z upon del y, and this function taken to left hand side minus, that is plus x squared del z upon del y minus xy del z upon del y. Del z upon del y is equal to nz, and from here x del z upon del x, and from here taking del z upon del y is common, del z upon del y is common, that is remaining is y plus x square minus xy is equal to nz y. This is the required partial differential equation of the studied function. Thank you, class.